Okay, today I'm teaching you the double angles. This is from 5.4 number 1, in case you're following along on a worksheet. 5.4 number 1. And the double angle identities, sine of 2 theta. That's a lot like saying sine of 60, for instance. Couldn't sine of 60 be exactly the same thing as this if I broke it up? Wouldn't that be the exact same thing as sine of 2 30s? Does that make sense to you? All right. So what is sine of 2 theta equal to? Here's the formula that they'll give you on the sheet. Sine of 2 theta is equal to 2 sine theta cosine theta. So wherever you see sine of 2 theta, you can write 2 sine theta cosine theta. That's just a simple substitution. Take the one out, put in the other. Why would that ever help? Well, if you see it sitting in a problem like sine of 2 theta over cosine theta sine theta, for instance, then you'd go, oh, I can put in 2 sine theta cosine theta, and then I have a sine and a cosine on the bottom, and cancel the sine and the cosine on the top, and the final answer would be what? 2. All right. So back to, there it is. It's in the box. I should probably box in the whole thing. That is your double angle for sine. I'll give you another one. Cosine, of course. So tell me how you think it starts. Cosine of 2 theta would be, and you want to take a shot at it? 2 cosine theta is right so far, except one little thing. It's got to be cosine squared theta minus 1. That's one you would not probably just intuitively have memorized. But again, you'll have a sheet. You'll be given the sheet. So you just got to know if you ever see cosine of 2 theta in a problem, you can replace it with this. Make sense? Why would that ever help? I'll give you a problem where it would. So for instance, let's say you had, let's see, cosine squared theta minus cosine of 2 theta plus 1. Let's say that was the problem in blue. What's the hint that something's weird about this one? The cosine what? Not this. That's not weird. You see that all the time. Cosine 2 theta. That's weird. You don't see that all the time. So you'd have to say, oh, so wherever that is, I can pull it out. And what would you put in instead? 2 cosine squared theta minus 1. Go ahead, do that. And then see if you can figure out the final answer. Replace what's in the parentheses with that little statement and simplify it. It's kind of a big day. You know why? Oh, it's not just that. I mean, it's a big day for you. This is your last day of learning new trig. This is it. Then you just have to study for the test, take the test, and then study for the cumulative test and take the cumulative test. But the last day of learning new stuff. Sit. I don't know yet. I haven't got that answer for you. I know that you need to know a lot of trig by Friday. I'll tell you more about Tuesday on Friday. Yes, sir. This test on Friday is just normal. There's just 8 questions. It's just that there's so many things to know, and a lot of them have like 5 answers, and some of them are extraneous, and you know, it's complicated. It's just not easy. All right. So how would you have done this one? You erase cosine 2 theta, and instead you put in this 2 cosine squared theta. Okay, some people are still talking. Please stop. Okay, now do you get that this and this can go? Oh, sorry, minus 1. Sorry. All right. I thought you were just blurting stuff out, but you were blurting out right answers. Okay, so that and that need to go together now. What do you get when you put cosine and minus 2 cosine thetas together? Negative cosine squared theta Okay, and then how about this negative here, and this -1, does this have to get distributed to that? Oh, yes, it does. And that makes it what? +1 plus the other one, which means +2. All right, I'll back up. Do you get, okay, right there. Do you get that this negative here applies to both parts? You need to get that. That's why that's a +1. And the +1 goes with the other +1 and makes +2. Okay, so I've given you 2 of these biggies. Now there's the third one. The third one is another statement like this that is off the double angles. And it's kind of confusing in a little way in that cosine of 2 theta is actually equal to 2 other things. So cosine of 2 theta has lots of options. I'm sure if I took the whole class period, I could explain why there's lots of things that cosine of 2 theta is equal to. But here are 2 other things you could put in for cosine of 2 theta. You could put in 1 minus sine squared theta. So if your problem had a sine squared in it, do you get that you might want to use that one then? Since you have a choice. Cosine of 2 theta can be 3 things. Here comes the third one. Cosine of 2 theta can also be cosine squared theta minus sine squared theta. So if you had sine squareds and cosine squareds in the problem, maybe I use the red one. See how 3 of those all start with cosine 2 theta? All right. So if they give you a cosine 2 theta in a problem, you got 3 things you could pick from that you could stick in. All right. That's the basics. If you understand that, then you can do any of these problems now. Now I'm going to start the process of reviewing for the test here, because there's a lot of things to know for the tests. And if I spend a full hour on this one little concept, and there's, well, you have to do 4R2s and 4R3s as 8 separate concepts that you have to be tested on. Could be in any number of permutations and combinations. Basically, I need some time to teach you some of the review today and tomorrow so that you'll be really ready for Friday's test. Yes, ma'am. You do not have to memorize these. These are going to be given to you on a formula sheet. All the other ones you do have to memorize. All the other ones we've given you okay, I should clarify. Except for the ones that you had on the top of the worksheet from yesterday. Those were the not double angles. Those were like, let me see if I can find one. Anybody have yesterday's worksheet nearby? There it is, thank you. Just to clarify, other ones that you don't have to memorize are sine of alpha plus minus beta, cosine of alpha plus minus beta, etc. Thank you. Okay. No, because you're the only person who would pay attention. So you can ask me that during work time if you want. All right, everybody, right now get ready to try some practice problems from the past. So get out some paper that you can do practice problems on. If you just want to turn the page in your notes, that'd be fine. And here we go. I'm trying to review a whole bunch of things now for your hardest trig test that you have. So let's say that you have cosine of tangent squared minus 1. Nope, I'm not going to make it that simple. Minus cosine is equal to 0. This is one of many skills that you need to have in the bank. Do you see what you're supposed to do here? What's the F word? Factor. Yes, that F word. You got to know how to factor these. Oh, I forgot all the X's. That's a good point. That's a good point. Doesn't really change how you're going to do the problem, but yeah, I needed those X's to make this a right problem. Okay, so do you see how there's a cosine in both parts of this? That's what factoring is about, is if you see one here and you see one here, you can factor it out. Okay, so the cosine comes out. And what do I have left? Tangent squared x minus, and then some people mess this part up. What I'm really doing is dividing by cosine x and both here and here. So what do I really have there? A 1. Good. And then I have two equations, both of which need to be solved. I need to solve this one, which is cosine x has to equal 0, and the other one, which I will do in a different color. Please stop talking out there. Tangent squared x minus 1 equals 0. Then I'm going to say tangent squared x equals 1. Can tangent equal 1? Yeah, but we first have to figure out the squared thing. How do I get that squared off of there? Square root, square root. What's the square root of 1? It's just 1. It's not plus and minus 1. It's not. But the square root of tangent squared x is absolute value of tangent x. Then that can break into two parts. Notice how they will be identical to each other, except for one thing. Negative 1. That negative right there is the only difference between those two equations. Then, can tangent be 1? Can tangent be negative 1? Yes, it can. You just have to think about it in terms of 1 over 1. This is not one of those quadrantal spots where tangent's opposite over adjacent, right? Can you make a triangle that has an opposite and adjacent that are 1? Yeah, you can. I get that one confused sometimes because it feels like it should be one of the quadrantals, like 90 or 180, but it's not. It's just a normal triangle. Where's tangent positive? All students take calc. Tangent's positive there, and tangent's also positive down there. So if this is going to be, I hope you've realized by now, 1 root 2, what's that got to be? 45. Good. And this one must be 180 plus 45, which is 225. But I better not leave my answers as 45 and 225. I have to change them into what? Radians. This is 45 is known as pi over 4, and this is how many of them? 1, 2, 3, 4, 5 of them. 5 pi over 4. Otherwise, you can change it the slow, painful way and multiply this by pi over 180. But there's my two answers, pi over 4 and 5 pi over 4. And that's just one part of my problem. There's so many parts. Now I got to solve this part. Where is tangent negative 1? Well, it's the same idea, except it's in this quadrant and that quadrant. And so you're just going to have to figure out what that is. It's going to be, let me think. These are pi over 4s. That'd be 1, 2, 3, 4, 5, 6, 7 pi over 4. And then this spot right here where tangent would be negative. Make sure that's right. Why isn't tangent also negative down here? It is. Oh, I just did that one. Okay, thank you. That's why I'm not doing that one. Okay, it's this one now, and that one is 1, 2, 3 pi over 4s. Okay, and then the last one here is just cosine equaling 0. That's going to be a hard triangle to draw anytime you have a 0 for a side, right? So it can't be a triangle, right? It's on the thingy, yes. So you have to figure out it's one of these. And which ones have cosine, which is x? Which ones have x equal to 0? Well, x is like this direction, right? Okay, so it's that spot and that spot. All right, so cosine will be 0 at pi over 2 and one other place, 3 pi over 2. And now, here's your 4 answers. No, 1, 2, 3, 4, 5, 6 answers for that problem. And it's still not done. You know why? Why? Somebody's going to figure this out. What's extraneous? What's extraneous? Okay, which function can have extraneous, like, there's only one function that can get crashed, like this. Sine, cosine, and sine and cosine can go on forever. They can do any angle. You can do sine of any angle. You can do cosine of any angle. But what tangent? You can't just do any angle. Remember what tangent looks like? Tangent looks like this. Tangent looks like that. Would you agree it can't exist at those asymptote lines? So it can't exist at pi over 2 or negative pi over 2. And then you got to think of what that means on a circle. Pi over 2 is here. Oh, tangent can't exist there, so we can't allow that. And what about that one right there? That one is negative pi over 2, but it's also known as 3 pi over 2. So, listen. Okay, do you agree by looking at the graph of tangent that tangent can't work for everything? Do you get that? Okay, so if we go back to this one, you might be saying, but we weren't solving that one for tangent, we were doing that for some other function. True, but if you go back to the original problem, which was right here, we had it all factored out, and you use pi over 2 in that problem, you'll be forced to do a tangent of a pi over 2? If you're solving this problem and you're saying that pi over 2 is a solution, because I said that right there, do you get that when you put in pi over 2, you'll have to put it in for x? Do you get how there'll be a pi over 2 right there? And there'll also be a pi over 2 that'll have to go right there. Are you allowed to do tangent of pi over 2? No. So what is the one function you have to watch out for? Tangent. And does that mean that if there's a tangent in the problem, there's always going to be something that's going to crash? No. But what are the two things that can crash tangent? Pi over 2 and 3 pi over 2. You could write that down. Those are the only things you have to worry about. Crashing. The only things that could crash you is if you had to do a tangent of pi over 2. Stop saying what and write it down. Tangent of pi over 2 and tangent of 3 pi over 2 are two things that can't exist. You can never have a problem with sine of an angle, because sine can go on forever and has no asymptotes. You can do sine of any angle in the world. You can do cosine of any angle you want. But you can't do tangent of any angle you want. If you do tangent of certain angles, it'll crash. What? You don't, okay, so what do I actually do? I go like this and I say extraneous. And I go like this and say extraneous. That's how I show the teacher that I know they were answers, but that they are not working because they're extraneous. Yes?
So if we have a problem that has like just cosine and sine, would we even have to check for...
That's a good point. If there's something with cosine and sine in it, it can't crash. Only things with tangent can crash. But that doesn't mean that everything that has a tangent in it automatically crashes. No. Tangent will only crash if it hits those two spots. These two spots. And these are called pi over 2, and that one's technically called what again? 3 pi over 2. Yes? Yes, but I tried to explain that to you, and I'll say it again. If you're saying that cosine would be 0 if it's pi over 2, you're saying that I should put in pi over 2, and that would cause this equation to equal 0, right? Because this part would equal a 0, right? But when you put that pi over 2 in right here, it will not just equal 0, it will crash. It will be, you'll have to put it in both functions when you put it in. So bottom line is, take all the answers that you have. And if there's a tangent in the problem, you have to watch out for it crashing. All right. Let's move on. I actually want to do some of the problems off your homework because otherwise this will go too long. You won't have time to do this homework. So here comes your homework. I'll pause for a second. I'll hand it out. So I just handed out worksheet 5.4, number 1. And I want to start with problem 4. Problem 4. Problem 4 says sine 2x is equal to 2 sine x. Sine 2x is equal to 2 sine x. All right, so on number 4, sine 2x is equal to 2 sine x. Do you see anything weird in here? Sine 2x. And so when you see that, right away you go to your list. Is that in the list somewhere? Yes, it just says theta in yours, so you can change that to x in your head. And which of these, oh, sine 2x, that's kind of handy because there's only one thing you could put for that. 2 sine x cosine x. 2 sine x cosine x, because it's given on the sheet. And I'm just bringing this straight down, 2 sine x. Now that I got the double angle out of there, the 2x, now it's just a normal problem. How do you solve these? Once again, set them equal to, and then use the F word. Factor it. All right. 2 sine x cosine x minus 2 sine x equals 0. Is there something in common in both of them? 2 sine x, you can factor it out. And I want to save time and not finish this because I think you know what to do now. You'd set both parts equal to 0. Set that equal to 0. Set that equal to 0. Okay? And then from there you'll solve. Sometimes you get answers that are, you know, that there is no answer. Like if they wanted you to make sine equal to 3, can sine ever be 3? No. Highest sine ever goes is 1 and negative 1. Okay. So let's move on. On number 5, what would be your first move? And don't say subtract sine x. That would be your second move. Number 5, what would you do first? Substitute out the sine 2x. Nope. It's pretty close. Not exactly the same. All right, flip it to the next side. Is there anything weird about number 6? Yeah, cosine of 2x. Now you got 3 choices. You got to think about which one would make the most sense. If you're picking between those 3 things that cosine of 2x can be, which one seems like it would get along well with sine x? Yes, 1 minus 2 sine x. Is that 2 sine squared x, I think you mean, right? All right. And could it have worked to do sine squared, or cosine squared minus sine squared? Yeah, that could have worked too. All right, but let's do the one that says 1 minus 2 sine squared x. So you're replacing the cosine x in the cosine 2x in the problem. And you're going to replace that with 1 minus what again? 2 sine squared x. Do you get how when you bring this sign over to the other side, you'll have a quadratic? Let's do this one together. So I'm going to bring that over, and I'll now have negative 2 sine squared x minus sine x plus 1. Yep, that 1 right there is a positive 1. Do you get that? Easy to get that backwards, but now, would you agree it's a pain in the butt to factor things that have a negative in the front of them? So you can fix that. How do you get all the signs to change? Multiply by negative 1. And you multiply by negative 1 everywhere. You times by negative 1 right here. You times by negative 1 right here. And you times by negative 1 right there. And you times by negative 1 right here, even though it kind of doesn't matter because 0 times negative 1 is 0. And all the signs will change. 2 sine squared x plus sine x minus 1. And all of that work to get it looking nice so it's a normal quadratic. See, you got something squared here, something not squared there, and a constant there. That tells me it's all ready to be factored like this. And then I have 2 sine x and sine x. And then how do I get a negative 1? It's got to be one of these has to be positive, one has to be negative. You figure out if it's that one or the other one. You'll have to do first outside, inside, last to figure out how to get the middle term to come out right. I'm not saying those two are right. You have to figure that out. And then once you're done, you set this equal to 0 and get 2 answers. Set that equal to 0 and get 2 answers. Okay, let's move on to number 11. Really common mistake on number 11. It says sine 2 theta over sine theta. you can imagine what some kids want to do because it would be so simple. Can't you just cancel out the sine theta and the answer's 2? No, you can't. You can't do that. It's not allowed. If this had been a sine squared theta, yes, you would have a sine squared on top and one sine squared on the bottom, and then they could cancel. This can't cancel. Whenever you see this sign of a double angle, remember, you can't do the problem as it is. You have to fix it. It's weird. So how do we fix the sine of 2 theta? We go to the sheet and figure out what is sine of 2 theta. What is it? 2 sine theta cosine theta. So I put 2 sine theta cosine theta there. And on the bottom, I still have sine theta. Now it's normal, and now I can start to work with it like normal and say, oh, sine on the top, sine on the bottom, they're gone. The answer's 2 cosine theta. All right, let me look at them. Sure. Can I just do, oh, I did one like. I think number 9 is going to be easy for you. There's only one thing you can substitute there. You get what you'd put in? The sine of 2x is, there's only one thing you can put in for that, so that's not going to be too hard. What were you asking for, 9 or 10? Yeah. Okay. On number 10, it's just 2 things. Sine of 2 theta, there's only one thing you can substitute for sine of 2 theta. It's on your sheet. You put it in. But the tricky part is that there's cosine 2 theta in the problem. And do you get how you have 3 choices on that one? 2 of them will not be good. 1 of them will work out nice. You just got to figure out which of the 3 you should pick. Substitute in for cosine 2 theta. All right. That's enough on today's worksheet. That gives you the idea of how this last topic, which is pretty much just if you ever see a sine of 2 theta or a cosine of 2 theta, you know you have to pull them out and put in something else. Use the identities, and those will not be something you need to memorize. They will be given to you. Just like on your worksheet last time where they gave you stuff at the top. All right, so let's do one more old review question, and this one I actually want to do right off of the review for the test. So I'm going to hand out now, this is not due tomorrow, this is due on Friday. This is your review for the test. So we'll do one of these problems together. So I'll pause for a second while I do that. All right, I just handed out the worksheet called Math Communication Number 5 Review. It's the big one. This is the big test I've been warning you about forever. It's hard, but if you've been paying attention, if you've been trying your hardest, if you've given all you've got, that's all you can ask. And some of you will get A's. Some of you will not get A's. The average in the class will probably be a C, at least if you're as good as last year's class. Maybe you're better. That'd be awesome. All right. Okay. So here we go. Number 1, part B. That's a lot of times confusing to kids because it's got a 1 plus tangent in it. And why is that confusing? Because if it was tangent squared, there'd be a lot of different things that would work and be easy on this. 1 plus cotangent x. If there is a 1 plus or a 1 minus something that's not squared, make sure you get the difference. If I had a 1 with the coat, what could I put in for that? Secant. I could put in a single thing to replace 2 things. That'd be awesome, right? Okay. Or if I had a 1 with the tan, what could I put for that? Secant. Okay. Or if I had a, let's see, if 1 plus tangent squared is equal to secant squared, what's tangent squared equal to? Secant squared minus 1. Okay. You can do a lot of that stuff. But that's only if they're squared. Okay. What if they're not squared? Well, there's a lot of different ways you could do this. A lot of you know that cotangent is the same as what? That's not sine over sine. No. Cosine over sine. Okay. Now, I'm not saying this is the best way, but this is a way. You could put cosine over sine for that. Do you get that? And what's tangent the same as? Sine over cosine. But there's a better way, because this way you'd have to get common denominators. Do you get how you'd have to have a common denominator? 1 plus this thing, and that's got a denominator of cosine x. You'd have to make this 1 into a cosine x over cosine x, and then you'd have to add them together and flip and multiply, and it would be ugh. So there's a better idea. If you have a 1 plus or a 1 minus, see if you can use this little technique. It's called using conjugates. All right, a conjugate in the simplest terms is this. If you have 1 plus x, you know what the conjugate of that is? It's really simple. 1 minus x. It's just flip them around. Okay? If I had 1 minus 2 x, it would be 2x minus 1. I just reversed them. Sorry, plus 1. Sorry. Plus 1. Okay. Now, why are these conjugates helpful? Let's make sure I didn't confuse you too bad there. If you want to multiply by a conjugate, then what's the conjugate to a 1 plus cotangent x? 1 minus cotangent x. And why is that good? Because when you do first, outside, inside, last on it, let's see what happens. First makes 1. Outside and inside cancel each other. That's kind of cool. And then what are the lasts going to give you? Minus cotangent squared. Ooh, I got something with a squared in it. And once I have something with a squared in it, all those other things come in handy, like the one with the code is cozy. All right, so what did I just do there? I multiplied by a conjugate. If I do it on the bottom, though, I have to also do it on the top. All right, so why did I do it? Why did I do that? Because now on the bottom, I did first outside and last. I got 1 minus cotangent squared x. If you go back to that saying that you know, the 1 with the coat is cozy, then do you get that cosecant? If I want to put in cotangent, I want to replace this now, I can put this 1 over to the other side, and I'll have cotangent squared equals cosecant squared theta minus 1. So cotangent is really this minus 1. Now I can put cosecant squared minus 1 in there. And the minus 1 and this plus 1 will cancel out. So what will I have? Negative cosecant squared. Okay, so what happened right there was I just multiplied by a conjugate. Do you have to do it that way? No. But if you do it the other way, you're going to have nasty common denominators to deal with. All right, so that's a method that will work well. I'll practice it with you tomorrow again. I'm not done. I'm not going to finish it. I'm going to let you figure it out from there. The top part, you'll have to multiply out. First, outside, inside, last. First will be 1s. Outside, inside, and last. All right. Okay, that's just one problem. Don't freak out. Now let's look at D as in donkey. 1 over secant x minus 1 minus 1 over secant x plus 1. What did I just tell you is something sort of the C. Conjugates. You should use conjugates to get your common denominator there. So 1 over secant x minus 1. And the other one was minus 1 over secant x plus 1. It's even like taunting you by saying, see, these are conjugates of each other. It's like, hopefully you'll notice that conjugates are going to be important here. So do you get you cannot add or subtract these until you have a common denominator? So to get a common denominator, we have to take the two denominators that we have. If these denominators had been 5 and 7, we'd use 35. You'd multiply them together, right? So we're going to get a common denominator here by multiplying by the conjugate. Secant x minus 1 And on this, and sorry, secant x minus 1. And then over here, I'll have to multiply by what? Secant x plus 1 and secant x plus 1. Then, what's special about conjugates like this? What do they make? They make things that have squared in them. The first outside, inside, last thing is what's special. So, if I go first is secant squared x. Outside and inside will cancel. That's part of the beauty of these. Because the outside one is negative secant x, the inside one is positive secant x. They cancel. And then the last is 1 times negative 1 is negative 1. And is secant squared x minus 1 anything? Oh, it is. What's the little saying we know about this, the sec? So 1 with the tan is what we seek. So you should write those down for yourself to remember what they are. So do you get, if I move the 1 over to the other side here, that it'll be the same exact saying except rearranged, is tangent squared is equal to secant minus 1. So secant minus 1, we have in our problem, can be changed into what? Tangent. That's the same saying as the 1 with the tan is what we seek. It's just been rearranged. So why did I do that? Because now the denominator of both of these fractions has just turned into tangent squared. Secant squared minus 1? It's sort of like saying, you know, why can't you take sine over cosine and just leave it alone? Well, it's better if it's tangent.
When you multiply by the opposites or whatever, don't the bottoms both equal secant squared x?
Minus 1? Yes. They both equal secant squared x minus 1. Okay, do you get why it has a minus 1 on the end or not? Okay, when you do this, I'm going to do over here because it's easier to read. Get how I have to do the first, outside, inside, last? Do you get that? The firsts give me my secant squared x. My outside and my inside cancel. Have you figured that part out yet? Okay, then what are the lasts? 1 times negative 1 is negative 1. Okay, so my denominator is secant squared x minus 1. But it'd be better if, since I know that this actually equals tangent, because of that rearranged 1 with the tan is what we seek, it'd be better if I say the denominator is actually tangent squared. So what happens is all of this here disappears because all of that is a common denominator, and that denominator is tangent squared. So now I'm just left with what's on top over tangent squared. And then another cool thing happens. This negative here gets distributed onto this and that. So I'll have a negative secant and a positive secant, and they cancel. And then I have a 1 and a, this one here, see, it's still there, that 1, and then this negative 1 times negative 1 makes positive 1, so it's a 2. So the top of this whole thing simplifies down to just 2. So the final answer is not secant. There's not secant down there anymore. What's on the denominator now? We replaced that with what? Tangent squared. So the top simplifies down to just 2. The bottom simplifies down to tangent squared. All right. I think we've done enough math torture for the day. So this review worksheet, you can start on it now, but it's not really due until Friday. The one that's really due is your other worksheet, 5.4 number 1. Stay caught up. If you want to think of it this way, guys, all you have left is tonight, tomorrow night, and then you will take the test and it'll be over. So even if you fail it, it's still over on Friday. Now you'll have a chance to retake it then, which is a good thing. But anyway, let's have you focus. Try hard tonight and tomorrow, and then all you have to worry about is taking a test. There won't be anything new assigned on Friday. Yes, and if you have to retake it, that pain will get over with quickly too, because that'll be done by the middle of next week. All right. Almost done with this stuff.